In this video, we're going to talk about the modern tuning system and talk a little bit about scales. So, when we're singing or playing violin, we can choose any note we like from the continuum of pitches, but most instruments are primarily restricted to playing from a limited number of pitches. So, the set of pitches that we can play form a scale. A scale is simply a set of pitches. We often think of scales as particular modes, but a mode implies we're going to use it in a particular way. For example, our major scale is actually an Ionian mode, and that has particular implications, which we study in music theory. There are actually many types of scales, so basically any collection of pitches can form a scale, but because in Western music we make so much use of sustained tones, we tend to favour scales that favour the small integer frequency ratios, so we can get more of a consonant sound. Other cultures may make use of different types of scales, especially if they are more percussive rather than sustained. There's some examples. One interesting thing is in other cultures, scales don't have to have equal steps, and they can use any kind of interval. Today, most of the music that we deal with, we use a compromise tuning, because a few hundred years ago, composers decided that they wanted to be able to freely change key whenever they liked, without retuning the instruments. So over the years we've adopted a system which can do that. What this means is we've retuned the various intervals, and they're no longer simple frequency ratios, so they're no longer just. The modern system, which we've been living with all our lives, is called 12-tone equal temperament. So 12-tone equal temperament is an example of an equal-tempered scale. In any equal-tempered scale, we still define the octave as a precise 2-to-1 frequency ratio, and then we have all the notes in the scale equally spaced. This means that the interval between each step of an equal-tempered scale will be the same, hence the equal in the equal-tempered scale. So what that means is each semitone, each step of the scale, has the same frequency ratio. So that means the ratio has to be some root of 2, and that root would correspond to the number of steps we want in the scale. So if we had a 2-tone equal-tempered scale, the ratio would be the square root of 2. If we had a 3-tone equal-tempered scale, then each interval would be the cube root of 2. If we had a 4-tone equal-tempered scale, we would have each interval being the 4th root of 2. We actually use a 12-note scale, so the interval between each note is the 12th root of 2, and that is a ratio of 1 to 1.059463094336. As an activity, we know the 12th root of 2 is 1.059463094336, so I would like you to calculate the frequencies of the chromatic scale, starting with C equaling 261.6. So we start at C, multiply 261.6 times the square root of 2, and that will give us the frequency of C sharp. And then we repeat that process all the way up the scale. One thing to note is because we've rounded off our C to be 261.6, our A, which we expect to be 440, isn't quite, but that's okay.